35 people in the call yet. Maybe we'll wait for a minute more and then get started. By the way, this is Satish Babu speaking. We seem to have an unidentified participant in the waiting room, which is the reason for the last message from the Secretariat.
Just to let all of you in the room know, when we have an unidentified participant in the waiting room, we will keep them there, as if we do not have the real identity, we will not let them enter the room for security reasons.
Right. Secretariat, are we ready to start?
For sure, it can start when you guys are ready.
All the speakers are in the call, so let's get started. So, welcome to this session, which is entitled as the Single Global Internet Technical Discussion. My name is Satish Babu, and I'm the chair of APRALO of ICANN at large. As you can see, this is labeled as a technical discussion, but we will try to simplify it as much as possible for the non-technical people amongst us, so that we all share a common understanding. And the central topic of this session is, as you can see, the single global internet and the factors that are perhaps impeding the evolution of the internet in this single global open kind of borderless fashion and taking into other directions. So I hope you're all keeping safe during these trying times. And one thing we realize when we look back upon the last 7 months or so is that the internet has become a lifeline. And the fact that all of us are meeting each other over the internet from different parts of the world shows how it is, how important it is today. And what really makes the internet so useful is the fact that it is a single global, well-governed, borderless, interoperable, and open communications medium. Of course, it has also other roles like a repository of information. However, in the last few years, we have seen certain developments that we can broadly label as internet fragmentation or attempts at fragmentation. This means that basically it is splintering or breaking up of the single internet into islands of connectivity, which are loosely coupled. That means they may be always connected or may not be. Now, fragmentation is a matter of worry for many of us, especially in the technical and policy communities. And people have actually kind of divided fragmentation into technical fragmentation, which is a technological kind of or infrastructural issues. That is the cause of the fragmentation. We have very famously at this right now in this time, we have the TikTok ban in the US, as well as the Clean Net initiative, which actually fall under the governmental form of fragmentation, which is a matter of policies. When government policies constrain or impede the internet's ability to freely connect resources in the internet, then we have governmental kind of fragmentation. And thirdly, we also have commercial fragmentation, where business practices create the impediments in free connection or free flow of information. Now, one of the things that have been happening is that the internet is very dynamic, and there are several new technologies which are coming up. And among these, the most well-known ones are things like IoT, which have to do with devices and sensors. We have pure software things like AI, ML, but we also have infrastructural developments like 5G. So, now what is the concept of fragmentation in the context of these emerging technologies? Or in principle, why is it so important that we have a single global interoperable internet? There have been reports that 5G, for instance, because it's so kind of infrastructural and also transformational. Now that's a claim. Earlier in the last session, Raj was saying that this is just a claim. We don't even use all the facilities of 3G or 4G, and we are now saying that quite similar to what is claimed during those times, that 5G is now going to be transformational. It's going to change it, everything. The way everything is going to be transacted over the internet. But there's also this concern that will 5G fragment the internet? Now, in this session, we'll try and discuss these issues and arrive at a common understanding of how the internet works. Now, this will be the kind of foundation part of today's session. And we will then move on to the question whether these new technologies could break the internet. Now, the initial part of the session will be dealt by my colleague from ICANN, Champika. Later on, we will move on to the two panelists, Anupam and Dalsie, who will speak from the technical and government perspectives. And finally, we'll open the floor for questions and comments. Before we move on, I'd like to introduce our panelists. Now, Champika Wijayatunga is well known to most of us. Champika works for ICANN as the Regional Technical Engagement Manager for Asia Pacific. Prior to ICANN, he served at APNIC and also in the IT industry, research and training environments. The next panelist is Anupam Agrawal. Anupam works for the Tata Consultancy Services and is associated with the India Internet Engineering Society. He is a past chair of ISOC Kolkata and has worked for many years in national and international standards bodies such as the Bureau of Indian Standards and ISO. He is also a member of ICANN's RSSAC Caucus. And finally, we have Dalsie Baniala. Dalsie Baniala is currently employed as a telecommunications regulatory advisor of the Republic of Palau in the Pacific. She was earlier independent TRB regulator, at the same time serving as the CEO for the institution in Vanuatu. During her time serving as a regulator, she also provided assistance and support on promoting internet governance at the national level in Vanuatu. It is notable that it was during her tenure in Vanuatu that the APrIGF was first hosted in the South Pacific region in Port Vila, Vanuatu in July 2018. So I'd like to formally welcome all three panelists, as well as all the audience and all the members of the Secretariat. We hope this will be good. This is going to be a productive discussion. And I'd like to request Champika to lay the foundation of the session. Over to you, Champika.
Thank you, Satish. Maybe if we can get the slides up. All right, thank you very much. And I hope that all of you can see the slides. So I think Satish gave a good introduction and a background about today's discussion and the context as well. So now, as Satish said, we have seen a lot of these new technologies, evolution of these technologies. We have seen, in the recent times, we have seen things like, as he said, AI, cloud computing, virtualized systems, and 5G, and so on. So our discussion here today is going to be actually pretty much focused in the 5G context and to discuss the importance of having internet as a single global network. Now, when I, next slide, please. Next one. Next one. Yep, thank you. So let me actually, because we are going to discuss about the internet, so let us discuss about the protocol that is actually involved as the base protocol, where the internet is all, the data communication is all based on. So as we may all know, it is TCP/IP, Transmission Control Protocol, Internet Protocol. So TCP/IP has been there for over 4 decades or so, and we have pretty much, all along, we have been using TCP/IP with all these new technology, evolution of new technologies, and so on. So in TCP/IP, basically, when the data communication happens, or when you try to send packets from one host to another host, we have a certain set of rules. And TCP/IP is based on a layered architecture. And as you can see in the slide, there are 4 layers here: application, transport, network, and physical. So application layer is the layer that users, humans, basically, interact with. And then where we have a lot of applications that run in this layer. In terms of protocols, so for example, if you consider things like browsing, we use protocols like HTTP, for mail, things like SMTP, and so on. So DNS is also in the same application layer. Then we have the transport layer. So this is where we have to package these data to transport. There are certain protocols in this layer as well. For example, like TCP and UDP. TCP is actually a more reliable protocol because it is kind of a connection oriented protocol, where what we say it has some sort of a handshake when the connection is established, which can take a bit of delays, of course, in terms of time, but it is more of a reliable connection, and you can do things like error corrections and so on. From the other hand, you have also UDP, which is faster, and we use, even where you need a lot of faster response times, we use UDP. And in the next layer, in network layer, which is we also call IP layer. So this is where things like, we give directions to all these packets, where it should be going, the destination, and so on. So that's where even things like IP addressing comes in, the routing comes in. So we use those protocols there. And then in the bottommost layer, the physical layer, so that's where we have the physical networks, the physical mediums. It could be Wi-Fi, could be Ethernet, fiber, satellites, and so on. And also we have things like identifiers in these layers as well. In the physical layer, we also have identifiers like MAC addresses, physical addresses, and so on. So that's the underlying protocol, the TCP/IP structure. So the internet, the data communication is all based on this set of rules, these protocol, TCP/IP. Next slide, please. Okay, now we also spoke about identifiers in different layers earlier. And then in the data communication, in the internet, we also use global identifiers as well. As I mentioned to you earlier, the application layer, which is actually more relevant to users, where we use actually more user-friendly type of identifiers or human-friendly identifiers, which is DNS, domain names. Even if you want to, browse the internet, you have a domain name out there rather than any address, which is actually not very user-friendly in terms of humans. So, but in terms of the connectivity, the data communication aspect in the IP layer itself, in the network layer, we use IP addresses. And we have been using different versions of IP addresses, 2 different versions mainly, IPv4 and IPv6. IPv4 has been there since the starting itself, and IPv6 also has been there now for like 20 years or so. IPv4 is a 32-bit address, as we know, and IPv6 is a 128-bit address. And then when it comes to routing, which means actually when you send the data packets from one network to another network to another network and so on until it reaches the destination, we have these another type. We use another type of identifiers, what we call an autonomous system number, or AS numbers. So autonomous system is pretty much a collection of networks with the same sort of routing policy. And so these autonomous systems also can be actually identified using global identifiers, and these are called autonomous system numbers or AS numbers. Next slide, please. Okay, now in terms of new technologies, especially focusing into 5G and the current model of internet. Now, before, of course, 5G, we have seen the earlier generations. 5G is actually the 5th generation wireless technology. And before that, we also have seen other generations, say, for example, like we even had 1G or so long time ago, like back in the 1980s. It was pretty much like voice-based communications, voice-based networks, and then analog voice-based networks, and then into 1990s or so, we have had like 2G. It was more of digital communication, but the data rates were higher than, of course, 1G. Data rates went into like kilobits per second or so. And then in 2000s, we saw that 3G. So 3G made a big change, especially with the data rates, where it was pretty much suitable for internet access, things like browsing and so on. It went to like few hundred kilobits per second, and then in 4G, which sort of happened like after 2010 or so, during the last decade, where we went to even much faster data rates into like hundreds of megabits per second. 4G, of course, has much higher expectation if you really consider the standard itself. But we also have, I mean, those are like theoretical limits. But then, for example, like even in 4G, there were definitions to go up to like even 1 gigabit per second, but it's only like theoretical limit. So that's why we have things like 4G LTE, for example, long-term evolution, where we have the current data rates going up to like hundreds of megabits per second. Now, so that has been the sort of evolution, and then in 5G we are talking like 2020 onwards or so for the next decade, probably. And here there are much more features have been expected in 5G. So there are, of course, different bodies that comes up with standards in relation to this. So there are expectations, objectives, what we want to achieve in 5G. For example, one of the important objective is, of course, the speed, the bandwidth, and we are talking about much higher bandwidth rates here, and going into things like even 20 gigabits per second, this kind of higher speeds. I mean, these are again, theoretical limits, and as I said, the expectations. And then also another aspect is that the low latency requirements, in fact, ultra low latency requirements, because with 5G, there are expectations where you have a lot of time-sensitive applications. It could be things like self-driving cars, where even a very small millisecond can create some issue. And then even if you consider things like, say, remote surgery type, that can be very time sensitive. So those sort of things might need a lot of low latency requirements. And then also another aspect is the IoT devices. So you would expect there are a lot of IoT devices within a small area. Say it could be even millions of devices within a small area. So even though they may not need a lot of bandwidth requirement, but still you need a lot of connectivity because there are a lot of devices out there. And then also another aspect could be even what we say V2X, which means vehicle to anything. So vehicles could be communicating with pretty much anything. So these are all different expectations, objectives that are sort of expected out of 5G in the years to come, basically. Now, I also want to get into this term called network slicing here. I mean, this is also why actually some are a bit worried whether the internet, whether it could be a potential threat for the fragmentation of internet. Now, network slicing is a kind of virtualization technique. We also have seen over the years the technologies, computer systems have been changing from hardware-based systems to even software-defined networks to even virtualized systems and so on. So network slicing is a virtualization technique. So in other way, it is there to abstract sort of network resources and network function. So even if you take, say, a mobile network, you would have things like a core network, you would have things like a transport network, an access network, and so on. So you can really create some virtualized slices, or in kind of logical slices for these segments. And then also there could be various other requirements. I mean, those earlier requirements could be common to different networks, because, say, for example, if a vehicle is moving from one area to another area, it could be moving basically, kind of roaming type of environments. But also within a single network, within a single carrier, the users could be having different expectations. Some users could expect some high bandwidth type of applications, as we said, like streaming kind of content. Some users could be expecting low bandwidth type of applications for connecting IoT devices, or low latency type requirements, as we discussed earlier. And then even some organizations might want to have their own enterprise networks as well. So there could be different requirements. And then we can also create these logical network or virtualized networks for those based on these network slices. So that is why actually why some have some expectation here. If we have these network slices or logical or virtual networks based on some sort of a private addressing scheme or identifier, that may fragment the internet. Next slide, please. Yeah, so could the internet be fragmented? Yeah, so if, say, some popular platforms, even now there are some popular platforms where you might have a large user base. So if some popular platforms want to, say, for example, if they want to work with certain carriers, say, for example, and if they want to have some network slice with certain characteristics for their requirements, and especially having some private identifiers, then that can create some fragmentation out there. But then the lesser known applications, not the popular ones, might still keep using the current model of internet, but then where you have large platforms, that they could still use their slices accordingly. Now, also we can view this in another perspective as well, because these 5G networks, or the slices, can also be considered as a special case of proprietary networks. Even now, actually, there are some certain IoT type devices, networks that runs on proprietary protocols as well. So those IoT devices, they have their own proprietary protocols, and they communicate using that without really harming the global internet. So that is that still happens, and this could be a possibility also. Next slide. Yeah, and then we have this question whether is TCP/IP still relevant? Yes, because in the first place, as I said earlier, we have seen all these different different technologies coming all the way, evolving for last many years, but we have still been using TCP/IP. And it is even, there have been discussions even earlier when 3G came, 4G came, and so on, whether the TCP/IP could handle this, whether we need to move away from TCP/IP and so on, but it has not really been the case. So TCP/IP has been able to handle that requirements. And also from IETF perspective, which is the standard development body in terms of internet standards, so they have done quite a lot of extensive work, especially in the last few years, especially to work TCP/IP or to IP-based and TCP-based protocols to work in very constrained environments. Say, for example, if you take working groups like 6LoWPAN or 6Low, so they have been focusing on IP, actually, work IP in low-powered networks, basically, like IoT type networks. And then also in terms of transport layer protocol enhancements, especially where you need low latency connections. There also have been some IETF working groups like Quick working group, where they work on reducing a lot of those cycles, iterations, where you try to establish a connection. Earlier I said, like, when it is TCP connection, there are certain SYNAC type, acknowledgements happen between the machines, and that can be reduced. And also you can add some extra level of security, things like TLS, and then combinedly you can reduce that iterations. So there have been a lot of work related to that, and so that shows that even in the future, it is possible for TCP/IP to face these challenges, face these expectations of 5G. Now, from DNS point of view, is DNS
Champika, you have 2 minutes more.
All right. In DNS perspective, whether DNS is workable in a 5G low latency environment, yes. Currently, of course, we see that in terms of DNS resolution, that happens further away from the edge networks. But it is possible that we can have DNS caches for the latency sensitive, like 5G apps, that can be local as possible. And also we can have distributed caching, so that we can have much more efficiency in the DNS resolution. And also another aspect, especially from IoT type of requirement point of view, we can also have DNS queries well ahead of the connection is made. Say, for example, like during the boot up process or during the start, these DNS connections can be made. Next slide, please. Yeah, so now the question is, okay, the moving ahead. So based on these studies, what is being carried out, we do not see really there's a need for any new identifier system. So the current existing global identifiers will suit these requirements, even though, of course, the expectations, as I said, there are different expectations, and TCP/IP should be able to meet those criteria. And a single internet, because we are talking about a single internet. Even current internet is a single internet, single network that can run a lot of these applications. So we are not running different networks for different applications as such. So a single network, single internet based on the global system of unique identifiers is the best way to maximize the benefits of internet. So I think that's what I wanted to convey. So as a start, and then I'd like to hand over to Satish. Thank you.
Thank you very much, Champika, for the presentation. I think you have laid down the basics of what we wanted to look into. I think the central point here is that while 5G does bring in a lot of advantages like the bandwidth or the latency, there is no need to kind of change the existing technologies vis-a-vis routing or DNS. And the DNS is perfectly capable of handling the loads that are anticipated, even with the 5G kind of speeds. So there's no reason why, there's no technological reason why anyone should try to fragment the internet. I think that's a good takeaway for us. Now we move on to our two panelists. I'd like to first ask Anupam to talk to us. I have two questions for Anupam. First is from a technical perspective, why is a single interoperable internet important? The second question is, besides what Champika has shared with us, do you have any other concerns regarding these new technologies like 5G that might result in internet fragmentation? So Anupam, over to you. You have about 5 minutes for these two questions.
Yep. Thanks, Satish. I hope I'm audible.
Yes.
Okay, great. So thanks, Satish, for these questions, and thanks, Champika, for laying out the context very well. So some of the claims in 5G are such that at times it feels that 5G will be faster than light, and the only constraint which 5G is having, that the speed of light is the limiting factor. So it is more like a situation where when you buy a new car, the maximum speed is 200 kilometers per hour, but that speed is calculated when you put up the car on a stand and with all the environment which is favoring that car, and it is asked and full acceleration is given, and then it reaches 200 kilometers per hour. So that's the theory part of it. But we all know that what happens to a normal car when it crosses 100, 120 kilometers per hour. So leaving those claims from 5G on the table and actually seeing that what is going to happen on the ground, the example is in our hands. So as Champika said, that IPv6 came around 20 years back, okay, and we are still to adopt it. So if in a system where just migrating from one identifier system, which is like IPv4, to migrating to IPv6, it takes more than 20 years. And we are now talking of a new identifier system under 5G. How will this interoperability will be maintained? How communities will be created? How the entire ecosystem will be managed? Nobody is talking about that. The only thing which is being talked about is that it is going to solve a lot of problems in terms of bandwidth requirements. Yes, I will agree to the fact that in the current model, there are issues both on the QoS side and QoE side. And the beauty is that these are being tackled by IETF in various working groups, be it the deterministic working group or be it in the ADD working group. It is being managed by IETF. And it is also a fact that IETF has been slow at times in responding to the new technological requirements, but those are being managed pretty well. In terms of to answer the first question that you require, why it is technically important that we should have one single global internet. The reason is very simple, that if we want to continue with this innovation cycle which is there, and the fact that still with one identifier system, there are still half of the world which is still to be connected. Introducing a new identifier system under 5G and then trying to reconnect the entire world, I think that's a very long haul promise which will break the complete innovation cycle. And the way the society has been tuned right now to use internet, that is going to be affected in a very large scale. So technically it is important that we preserve what is being done now and then try to see what are the challenges and solve them. Yes, I will agree to one point that IoT, and particularly in case of IoT, when privacy needs to be managed, there is a requirement of a new identifier system. And when I say that, I can also add to it that the new identifier system can very easily work under the current DNS mechanisms which are there. So we'll have to look for the new identifier systems from the use case point of view, particularly when there is a machine-to-machine communications requirement. There might be a requirement, but then creating that new system as the one global system, technically, I think that will be a bad move to go ahead, because essentially there are not going to be enough resources and the complexities will be too much for all of us to manage, to make sure that it works the way the current internet is working. Additionally, we will also have to appreciate that internet is fragmented in some sense today as well. If you look at the fact that there are certain websites which are only IPv6 enabled, you generally cannot access those websites now from a normal IPv4 network. So yes, we will have to appreciate that internet is fragmented in some sense, and that is the reason we come back to this topic of fragmentation and again and again. So at the content layer, if you see, there are applications by content providers which are geo-IP tagged, which means that the same movie which you can see in, say, US or Canada, you cannot see it in India or Nepal or Australia. So that is some kind of fragmentation, definitely. And if there are censorship issues, which Satish, you mentioned in case of TikTok and others, that is also a kind of fragmentation, because the same application is being accessed by people from different places, but not from a particular region. However, if you look at the logical layer, which is where the protocols and the parameters are there, I think the basic idea of the protocol is to ensure that the packets, the data packets are formatted, addressed, compressed, and then transmitted over the IPv4 or IPv6 network. So at that logical layer, if we go ahead with the fragmentation, I think we are going to have challenges at a global level, which will be, and the benefit of those systems will far outweigh the benefit, and the benefits of doing that will be much less than what those complexities are going to be there. So we will have to appreciate the fact that internet might be in a discussion where fragmentation is being talked about by introducing a new identifier system, but technically I will support the fact that the challenges are there. It is not that the current system is absolutely perfect, but there are efforts which are being made by the technical community which exist around IDF to solve those problems, and that is the way forward for all of us. Satish, I'll stop here and then we can take questions.
Thank you very much, Anupam, for delineating those points. I think very important. Before I move on to Dalsie, I would like to, there are 2 points that I'd like to make. One is that if you have questions, please post them in the chat or raise your hand, whichever is your preference. If you post it in the chat, we'll read it out. If you raise your hand, we will see whether we can give you a speaking slot. That's one point. The second point is that Dalsie is having problems with her internet, so kindly bear with us. If there is a problem, she is going to stop using the video, but I hope there is no issue. And my questions to Dalsie are the following. From a government perspective, do you have any concern on internet fragmentation? The second question is, now we know that governments need to play a balancing act to protect their citizens' interests, while also recognizing that a single interoperable internet has allowed us to enjoy many benefits and have changed lives. So how do you balance these 2 opposing forces, and what are your insights on this? So over to you, Dalsie.
Okay. Thank you very much, Satish, for this opportunity. And I also wish to thank the hardworking committee for putting this event together. And also thank you for the invitation to be part of the
Dalsie, we seem to have lost you.
It's just happened again. I'm so sorry.
Yeah, we just lost you for a few seconds. Can you continue?
Yeah, thank you. So back to the questions that you have asked, I'll be very general and importantly making reference to policy and regulatory perspective, and at the same time at the user level. So in fact, there are many internet users and leaders today who are very concerned about internet fragmentation. And I would like to share many of those views and from experience as a non-technical user of internet. So we all know that internet play a key role in achieving sustainable development goals, and is the message that we continue to hear from all internet governance forums in both international, regional, and even at the national level. So if internet is recognized at all levels to be the key contributor to achieving the SDGs, let's step back and ask ourselves, what are we lacking or need to improve on to move forward with the key actions and deliverables that we believe will positively impact the unfortunate population. Take, for example, goal number 9, which reads, build resilient infrastructure, promote inclusive and sustainable decentralization, and foster innovation. The big words in there is for the specific discussions are resilient infrastructure and promotion of inclusiveness. So if we are to go further down and learn from the national government's contributions to internet development to deliver on those sustainable development goals, let's refer back to many of our national policies and roadmaps, including ICT and internet. These policy directions are loud and clear to continue to promote the importance of internet as an essential infrastructure for all this development, if we are speaking of the SDG goals. Moreover, at the national level, the main challenge that we are all facing, and I take, for example, the Republic of Palau, has very, very limited technical resource. And if the policies and regulations in place that mandate us to roll out access to internet services, and is where our focus is, and at the same time trying to catch up with regulatory framework to cater for these internet activities, including data privacy, cybersecurity, and more others, then comes the impact of internet fragmentation. There is definitely an issue for many of us leaders to work on. Let's go further on the main concerns that, in my views and experience, are stimulators of internet fragmentation. Cost of access to the global internet is one major problem. Comparing a small island state like the Republic of Palau with international business centers in New York and London. Then comes the ability to use reliable cloud-based services in unique and small island states like Vanuatu, with the impacts for e-commerce, e-government, and more others. Let's also look at the ability to use content services, for example, Netflix and more others, that might be copyright restrictions at the national operations that could limit the ability for us to have access to these content services unless we choose to perform illegal access, which we do not encourage any of users of internet or listeners or this session. Access to e-building blocks is another concern, such as e-payment systems, and at the same time, physical delivery of payments. Again, this is already a challenge that is impacting and could impact the potential of local e-commerce businesses, not to mention assurance of the rights of the citizens in terms of protection of their data, but also law enforcement, the ability for police force, for example, to obtain evidence from overseas. I would expect that would be practically impossible. So in fact, some of the arguments are, in my view, only potentially problematic, and others may have been identified as actually problematic. So if It would be foolish for any internet users or leaders in the world of internet to think the internet fragmentation problem will just go away, as some leaders have thought would happen with COVID-19. But for me, going forward in an inclusive way, it would be appropriate to identify the highest level of problematic examples of current or highly likely potential fragmentation of internet at the technical, the content, and transaction layers, a number that is workable, then weigh their respective significance and the necessity of taking steps to redress both at the national and international level with a direction and link through UNDGs. From there, maybe the actual steps to overcome the problems or issues need to be determined and shared on a worldwide level to get common agreements and an action plan put in place. The action plan must have clearly defined outcomes required and a time frame for them to be met. In this way, implementers would have a guide to follow at any levels. Thank you.
Thank you very much, Dalsie, for that very illuminating intervention. Obviously, what you have pointed out is very important. There has to be concerted effort at the international and national levels to address this problem. Coming from the ICANN at large, I am also concerned about the end user, the person at the last mile. So what we need is a process that takes into consideration the aspirations of end users also, with the the priorities of the government, as well as with participation from the industry and technical communities to address this problem. We now open up the floor for questions. We have close to about 13-14 minutes. So I see the first question from Joyce. I'll read out the question and I'll request any of the panelists who want to address it to take the question up and respond briefly, because we need to maximize the number of people who can ask questions. Joyce's question is, what is the problem with internet fragmentation? What impact does fragmentation have? Conversely, what is the value of having a global interoperable internet, and is it really necessary for it to be interoperable? Who would like to take this question? Champika, would you like to go ahead first?
I think I can take some aspects of that. In fact, actually, even in Dalsie's explanation, I think she had answered quite a number of those aspects actually, which can answer that question actually. Even I can think of, especially even from a say from 5G perspective, if you really consider the spectrum itself, that is quite broad. And say, for example, if a certain player is given a quite, say, a big chunk of that spectrum for whatever the gains or agreements with the carrier and the platform, of course, then some may lose actually, because a large amount of resources is really allocated to one party. So if you are not in that network, then you might lose. So these are some concerns some would have, especially if the internet is fragmented. I'm talking about. So I mean, these are some examples I could give, maybe from different other perspectives, from say governmental or civil society's perspective. You might want to add further. I think Dalsie has added a number of points as well during her talk.
Right. Thanks very much, Champika. Anupam or Dalsie, would you like to respond to it quickly within 1 minute?
Satish, this is Anupam. Can I come in?
Yes, please. Please go ahead.
Okay. So the question that why is it necessary for internet to be interoperable? I think the reason is this conference itself. Like, if this would not have been interoperable, we might not have an APrIGF in a virtual edition, because somebody in some country is having a different device, or somebody in some country is having a different platform. So it is the core principle of internet that it has to be interoperable, and it has allowed organizations like Facebook or Google to become such a big organization, and that also gives support to millions that if they are doing something right, tomorrow they can also be organization, or their product can also go at a global level. In a fragmented internet, in a non-interoperable internet, I think that is something which will lose greatly. The entire innovation cycle will come to a stop. Thank you.
Thanks, Anupam. Dalsie, would you like to go ahead?
Thank you, Satish. I think it depends very much on which angle you're coming from. Take, for example, if you are coming from, you are speaking or you are asking question from a user perspective, it depends very much on your experience. And for example, you know, if we don't have the capacity to have for example, build an e-commerce or have access to building blocks or such as e-payments, that's already a fragmentation. For the policy perspective, if you don't have the capacity and to develop a policy that will guide you, you know, for inclusive internet, then that is already a fragmentation. So I'm just giving an example just to give you some insight as to where you're coming from, you know, and trying to understand internet in fragmentation. So.
Thank you, Dalsie. We'll move to the next question. The next question is actually about a slightly different process, which has been called as internet consolidation. It's a long question, so I'll quickly read it out. Should we be alert of social media growing as strong as ever, where companies like Facebook is starting to be multitasking, where you can use it for news media, awareness raising purposes, advertisement, communication, education, or even connectivity? Facebook also bought Instagram and WhatsApp. All Facebook needs to provide a service where users can search what they want, like Google does. And we are really looking at a potential monopoly-like business platform where abusive and bullying could lead to physical and permanent impact on the community. So consolidation, especially by big tech. So looking at the time, we don't have time for all the three panelists to respond to this. Would any one of you like to volunteer to respond to this question on internet consolidation?
I think it's quite technical, so let's hear from Champika.
Yeah, Champika, you have been volunteered. Please go ahead.
Yeah, I mean, as I said, you know, it is. It all depends on, say, for example, if that, say, the mentioned platform, if they want to have their own private network, say, as I said, you know, say if they want to have a certain allocation of the spectrum as well, and if they want to have their own private identifier system, then of course there is a risk that the fragmentation can happen. But the thing is, again, you know, you have to look at this from a different perspective as well. Now, again, as Anupam pointed out, we are talking, you know, the benchmark for these considerations are things like the speed of light. So in that case, from that perspective, we are talking here in the range of, say, if you take like 10 milliseconds or say 1 millisecond, you are talking in the range of, say, hundreds to like thousands of kilometers, right? You know, considering the range, the distance. So in that range, you are really talking about local or regional networks, not really global type networks. So that would not really have too much of impact as well, because, you know, even in that kind of a local regional type network, you could still have some private identifiers without harming or without affecting the global network itself. Yeah.
Thank you, Champika. We have several more questions, so and we have limited time, and we also have a session right after this session, so we don't want to kind of take any longer than we could. I'll read out several questions. One is about geopolitics. Does geopolitics affect fragmentation more seriously? That's one question. Another question is how, okay, I should mention the names of the people. The last question was raised by Kwa Zolin. The question on geopolitics by Yingchu Chen. The next question is by Dr. Govind. How will 5G fragment the internet, as the internet is it's a network of networks where 5G is one of the networks only? And I'll take one more question here and you can combine your responses. Can you please highlight what, if any, would be the impact of low Earth orbiting satellite mega clusters like Starlink on this issue? Are there any, would any of the panelists like to respond to any of these questions?
I can take actually Dr. Govind's point. Yeah, actually, that's the point that we are trying to emphasize here. 5G, if you really consider 5G, it's another access technology, just like 3G, 4G, and so on. So it is just another access technology, and you really don't need to have a different sort of identifier system for that, and that's the whole point. Or you don't really need to have that fragmentation out there.
Right. Does anybody else want to respond to any of the other points?
So Satish, I'll respond to the question by Yingchu Chen, that does geopolitics affect
please go ahead.
Yeah. So the nature of internet broadly is cross-border. Okay. So you can access internet from one country to another, whereas the countries do have a border, and increasingly countries are trying to extend their border into the cyberspace as well, and that is where the geopolitics come into the picture. And the example is if some country doesn't allow some of the websites or some of the content which they think at the government level that it should not be accessed, that is definitely going to create fragmentation of the content layer. It necessarily doesn't fragment technically, but because the same content is not being able to be accessed by few in a particular geography, because of the geopolitics, I think that is definitely some kind of fragmentation, which we'll have to agree that yes, geopolitics does have a part.
Thanks, Anupam. I see a hand up. This is Yik. Yik, would you like to make it very, very brief?
Yeah, I think my question is when we talk about fragmentation, I think just like last speaker just mentioned, we need to talk it in a different level. For example, like a content level, infrastructure level, and the data packing level. I just want to make the comment about that. So the content level, maybe there's a fragmentation, but I think in the infrastructure level and the technical level, we need to have a unified platform. Just a comment. Thank you.
Thank you very much. We will now maybe take one more question. I think there's a question from Felix. Does fragmentation of the internet offer customized services for a fee? And I'll take the last question also from Samrit. One of the measures which countries took to stop the spread of COVID was to stop all international flights. While physical networks and threats is obviously a very different context, is there some merit in being able to exert such an influence, i.e. block certain parts of the network in the online world as well? To be able to do so, wouldn't one global single internet be a hindrance to do that? What would be the downside of having a single global internet? Right, so anyone would like to respond? We have another 2 minutes to go. Okay, so let me give a comment from my side. I think this goes, I mean, the ability to basically censor, some part of a network. This goes into a place where we do not want to be, because that goes against our generally established principles of a common global open borderless internet. And this is exactly what fragmentation is. And unlike COVID, I don't really, I can't see a use case for a situation where you would like to, block part of the network. Now, the often cited use case is national security. But national security has to be balanced with what? With the global public interest, because you can't go off on a tangent on national security alone, and it has to be balanced with the other forces, because even though an individual user out of the several billions of internet users is a small user, when you put together all the billions, then it becomes a global interest, public interest becomes a real tangible force. So therefore, this particular proposal to kind of restrict parts of the internet will kind of go counter to the global public interest, and therefore many of us would have issues with that. But we are aware that some of the countries, some of the states are actually doing this sort of a thing. Now, I would like to stop here. I'd like to thank all the participants, and I'll for a very productive discussion, the panelists and the participants, and I'd like to pass it back to the Secretariat for the next session. Thank you, and bye.
Thank you, Satish, and everyone for attending the session. Before we end the session officially, are you 下次要 show 個 slide 講埋，即係叫佢哋。Okay, wait, hold on. Why disappear on my right side? So before we end the session officially, I would like to invite all of you to join us at our Internet Happy Hour after this long day at APrIGF this evening, and would like, of course, to remind all of you to input your opinion and comments on our synthesis document and support the global IGF movement. You may find the details and information on the screen, and hope to see you all in the upcoming session.
Bye.
Thanks, everyone. Bye.
Thank you all.
Thank you.